Hey there, mathletes. Let's go over section 6.4. We are going to look at the graphs of sine and cosine. Just on a side note, sorry if it was a little confusing on the last section. I forgot that the last video I did was the last part of the section. Whoops. Oh well. Okay, so anyways, section 6.4. Let's graph sine and cosine over the interval -3 pi to 3 pi. Okay, so it's a pretty wide interval. So sine starts on the origin and then it's a wave shape in both directions. Just like that, and then on the other side, just pretty much draw a wave. There you go. And sine is kind of nice because its x-intercepts are those whole number times by pi. So that would be 0, pi, 2 pi, and 3 pi. And then the same thing on the left side, just negatives. And sine is going to bounce in between 1 and -1, and it actually hits those two values at the top of the hills and the bottoms of the valleys. There you go. So the graphs are going to be pretty similar to these as far as the shape and what you're going to be required to label. Like, I don't necessarily need the x value at those max and mins unless you just want to put them in there. I'm just interested in the shape of the curve, what it bounces in between, and where are the x-intercepts. All right, cosine, it's also a little wave, but it's like you've taken the sine curve and you've shifted it over by pi over 2. So these values kind of go over to the left. So this point up here, the max for cosine, that's the y-intercept. So then it's a wave going like that on both sides. All right. So cosine, though, those whole number values of pi, those are where the max and the mins actually are. And same thing for the left side. Just kind of drew it a little bit past 3 pi, but oh well. So the intercepts are actually going to be the pi over 2s and 3 pi over 2s and so on and so forth. And the same thing over here. And just like sine, cosine bounces in between 1 and -1 typically. Okay, so let's look at this little theorem. So these two graphs you should have seen in your trig class before. You should know that's what they look like, that's what the intercepts are, and so on and so forth. All right, so the theorem says for y equals a times sine of bx and y equals a times cosine of bx, the amplitude or the amp is the absolute value of the a, so the number that's in front, just make it positive, or if you didn't have the actual equation, it would be the max minus the min divided by 2. So not quite an average because you're subtracting, but it's the top of the curve minus the bottom of the curve, and then you divide that by 2. And then the period, or the length of the curve before it starts to repeat itself, is 2 pi divided by the absolute value of b, or whatever number is being multiplied to the x. And sometimes it's a fraction, so be careful. All right, example 2, write an equation that models the given graph. So this is where we're going to need that max minus the min over 2 to figure out the amplitude. So let's talk about what an amplitude actually is. The amplitude is the distance from the center of the curve to the top of the curve, or the distance from the center to the bottom. So you can kind of cheat and bypass this if you want, especially for these basic ones, because it's not that hard to figure out the center. It's probably at 0. So like for here, the distance from 0 up to the top is 3. So that's your amplitude. Now, the b value comes from whatever the period is. So for this curve, it's the length before it starts to repeat itself or to start drawing the same exact shape. So it's just the section that I traced from 0 to 4 pi. So the period is 4 pi. So what you do is you set it equal to that little 2 pi over the b. You can drop the absolute value bars. The absolute value bars are really just in there from when you're working from the equation. You don't need them when you work backwards. So 4 pi equals 2 pi over b, and then just solve for b. So in this case, b is going to be 2 pi over 4 pi, or half. So once you have the a and the b, you can throw it into one of these two equations. You just have to decide which one is which. And because it's actually hitting the origin, that's going to go off of sine. So y is going to equal 3 sine of 1/2 times x. Or you could say y equals 3 sine of x over 2. You can multiply the x and the 1 together if you want. Either way you go is totally fine. Okay, let's go ahead and do part B, and then we'll stop the video just so we can finish off the page. So the center of the curve is right on 0. So the distance from the center to the top is 4, so that's your amplitude. The period, sometimes it's easier, like if you don't like drawing it from the origin and so on and so forth, you can just kind of go from top to top. So from that point to that point, or from bottom point to bottom point. If you're going off of the origin, it's kind of like you have to get 3 intercepts, but top to top, people can get that pretty well. So from top to top, that distance there is, looks like it's 18. So set it equal to 2 pi over b. So b is 2 pi over 18, or pi over 9. And you're not hitting the origin, so let's go off, or go with cosine. So y equals 4 cosine of, I typically like the x in the numerator instead of off to the side, so we'll write it like that. But you can write it this way if you want to. You could say pi over 9 times x, either one. Okay, so that's a pretty good introduction to this section, so let's stop here and pick it up in the next video.